of the symptom. So now you will probably ask, well, partial discharge equipment exists already. They have been around for 25 years, and why not do PD discharge? Well, PD measurement are very complicated, and it's a black art. You buy it and you hook up for life with these guys, and only they can help you interpret the data. So what we want to do is make it easy. Well, you understand temperature, right? You understand hotspots. These are common sense idea that everybody can take a look and say, this is the problem. Okay? Now, PD also can be tedious. Sometimes you have to wedge an antenna, you have to remove the top bars, and that will take a long time. It's not something so simple. And here comes our hypothesis. Okay, so what can you do to monitor PD activity without using PD measurement? Okay, so the physical phenomenon is this: if this is this PD is arcing events, and then you see, whoops, oh no. You see the lower left-hand corner, and in a cycle there could be clusters of these. And rather than seeing the dot pattern and trying to interpret it, we say that if all this discharge did take place, then there should be a local temperature rise in that vicinity as monitored by the sensor. And so that is what we provide. With this advanced vibrofiber sensor, first you notice there's a difference in color. It's made with the material that can stand up to 250 degrees C. So it is, because if we want to measure temperature, these hot spots, let's say you have a large generator that is hydrogen cool, and then there will be water cooling jackets on the end winding. So you don't expect the temperature overall to rise beyond 100, but locally, remember the Tata hydro turbine caught fire? So it did get beyond 100 degrees. And so our sensor can tolerate spikes of very high temperature, 250. Now, of course, to lead up to a fire, you probably have temperature even higher than that. But we want to catch it, maybe shut down before that occurs. So at this stage, our solution consists of mounting on the end winding, shown here in the cross section, and then in addition, place it to at the same winding closer to the edges of where the rotor and the stator interface. This is the only gap that we can. Now, we are working on a next solution called stator guard. Remember that one fiber can carry 30 sensors? Well, this one, however, to install it, requires removing of the rotor. So, but this thing can be lined up to all the stator bars, the rails, and be able to tell you whether things are tight directly, called the stator guard. And another product can also measure vibration right at the stator. The end winding is actually just an indicator, it's a mechanical amplifier. The vibration starts at the stator core and then got amplified with the end winding because things are not supported. Okay? Now, so several generators are notorious about this. They didn't know when they designed it. So they are Mitsubishi, Alstom, and Siemens. Okay, that the vibration become very obvious. So beyond the end end caps, and these are the locations that we recommend. And so far, any question?
So how many of those would be inside the generator?
Okay,
You're getting to that again.
good question, yeah, good question. Remember we said there's a tangential in the radio position. And for a typical three-phase machine, so you have 6 free pairs on each end, exciter end and the turbine end. So typically you got 12. Now, we make it 12 for the OEM because they don't need any more. They said they don't need that. Now, however, our TG guard has 16. So allowing you to use 2 extra sensors where you want it to measure temperature rise as well. Now, the thing is, temperature rise at the end winding is important because that's what Tata found out. But temperature rise should be detected earlier inside the core. So we recommend 6 on each side, 8 on each side, making 16. Well, the advantage of our solution is that we simplify the architecture. And one thing is that there is a hub. This hub, if it's hydro, then it's a simple junction box acting like a distributor to the sensor inside the generator. If you have a hydrogen-cooled machine, then we provide you with a hermetic sealed junction block. Okay? And outside of that junction block are terminals that are color-coded. And this color-coded fiber optics cable can go up to 100 to 300 meters away. This is the significant difference between optical solution and electrical solution. Electrical cannot have long cables, they pick up noise along the way. Whereas this, the technology actually telecom use is up to 20, 30, 40 kilometers. So when I say 300 meters, I am being conservative. So it can be done like that. Now, essentially, then the composite cable breaks out again, linking up to our box. Our box provides the light source and then the signal conditioning and then interpret the result. And this is the picture for the OEM where they have their own data acquisition unit. We output analog voltages directly fed to them. Okay? For TG guard, our machine takes off and give you the direct signal, which I'm going to show. So this is the place where we installed at the end of November last year at AEP Perky plant in Marshall, Texas. And it's a fairly large plant. And our field engineer is standing in the exciter end when the belt is removed. And fairly large machine, 775 megawatts, made by Westinghouse, 25 years old. Okay? And voltages are 24K, so it's high voltage. So 6 sensors were installed in the exciter end. You can see the cables here and there. And 9 o'clock, 11, 1 o'clock, 3 o'clock. And on the other side, there were, instead of 6, there are 7 because the 7th sensor was made to mount directly on copper. And the customer wanted to try an experiment just to see temperature because the winding had been wrapped. So if the sensor is mounted on the top of the wrapping, so we are concerned about the thermal conductance of that insulating layer. So by the time we finish, you can hardly see them, except that there's a little dark shadow here, a little dark shadow, well, I can't even see it here. Okay, these are where the sensors are. And after we finish installing them, we wrap them, we paint them. And so it's completely transparent, and it will